All right, the Pythagorean Theorem. This is going to be chapter 11.4 in our algebra book. This is a picture of what someone thought Pythagoras might look like. Pythagoras was a ancient Greek philosopher and mathematician. The two sort of go hand in hand back then. He was from a small island in Greece. He was, I don't know, I think he was born somewhere in the early 600 BC, like 610 BC, something like that, and he died, I think, around 570 BC. Something. Those are probably the best estimates, I think. Anyway, Pythagoras is credited for this Pythagorean theorem, although much of the research says that the ideas for this existed well before him. I think he's just one of those guys who is lucky enough to get his name attached to something because he wrote it down, and sort of the histories of math have him using it, and we don't necessarily have histories of the Babylonians or even some of the Indians using the Pythagorean theorem or this idea, so we give it credit to Pythagoras. Okay, and that's why it's called the Pythagorean theorem. All right, well, let's go on. Let's take a look at what this thing actually says. Okay, well, I know a lot of you guys know the formula for the Pythagorean theorem, but what I really want to do is let's take a look at the idea of what it actually is talking about. It's a pretty cool thing, I think. I mean, it's pretty amazing. So what I'm going to do here is I'm going to draw some squares, okay? And I'm going to draw some squares. I'm going to try to make a triangle out of them. So I'm going to start. This is sort of the basic Pythagorean, what's known as the Pythagorean triple. And what I'm going to do here is I'm going to draw a, let's say I'm going to use a square. I'm going to make it 4 by 4, okay? So this is going to have an area of 16 spaces, right? So I've got this thing. It's 16 spaces and it's 4 wide, right? Each side is 4 units long. Okay, so when you multiply it, 4 times 4, you get 16. Okay, well, let's do that, and then let's say another square. Let's make, we'll say a red square. Okay, so we'll make a red square, and let's do this one. Let's make it the side length of 3. Okay, so this one is a side length of 3. So it's a 3 by 3 rectangle. Oh, I'm sorry, 3 by 3 square. I'm going to pop it in over here. Okay, so it's going to create the two sides of our triangle. Okay, and because these two meet this way, you're going to end up with a right angle where these two are. Okay, and so I know that this side length is 3, right, and then the other side length is 3, and so it has a total of a square of, or an area of 9 square units. Okay, now the idea behind the Pythagorean theorem says that if you take this square, the area of the square, and you take the area of this square, and we add them together, okay, we get 25. All right, and so what we're going to do here is let's draw a square that has a unit length, right, or that adds to have an area of 25 units, right, because 16 plus 9. All right, 16 plus 9 is 25, so I need a square that has an area of 25 units. Well, that hopefully you guys can see is going to be, whoa, that's a crazy looking line. Not a square at all. So let's say we'll do 1, 2, 3. No, that's not what I want. I wanted it to be green and white on the inside. So let's do this. So 1, 2, 3, 9, 16, 25. All right, so we've got 125 units. So let's take this square here. What I'm going to do is I'm going to move it over here, and I'm going to kind of attach it to these two and try to create a right triangle and see what happens here. So if I take this and kind of angle it, and I kind of move it over and drop this guy in, say right about there. Oh, there we go. And it creates a right triangle. And when we built this square, we knew that it was 25 units, right? And we actually built it so that it was 5 units across, okay? So what we end up with is a triangle in the middle here that has a side length of 3, another side length of 4, and then a longer side of 5. Now, hopefully you remember that this side and this side, the two sides that create the right angle, are what are known as the legs. And this longer side, the one that's directly across, right, the one that's across from the right angle, is called the hypotenuse, okay? Hypotenuse. Okay, the hypotenuse. And what the Pythagorean theorem says here is if you create a square, okay, from the two legs, right? If you create squares of the two legs, and then you put them, add them together, okay? You take the sum of the squares of the two legs, it will equal the square created by the hypotenuse. Okay? Now that's the Pythagorean theorem. The formula that we use for this is a squared plus b squared is equal to c squared. And what this says is the leg, all right, the square created by the leg added with the square created by the other leg is going to equal the square created by the hypotenuse, right? So the area of the square of one leg added with the area of the square of a second leg is going to equal the area of the square created by the hypotenuse. Okay, that is the Pythagorean theorem, and we can use this for all kinds of interesting different applications. So, well, let's move on. Let's just practice using it a little bit since it's probably been a little while. And so what I want you to do is I want you to find the missing side. Go ahead, use the Pythagorean theorem, and go ahead and pause this video and find the missing side. All right, well, hopefully you said, okay, you know what? This is going to be a squared plus b squared plus, is equal to c squared, okay? And what I know here is I know one of the legs is 6, okay? I don't know the other one. We'll call it b, and that's going to be equal to the hypotenuse, which is 7, and we're going to make that 7 squared. Okay, so now let's go ahead and we're going to solve for b. All right, we're going to find a missing leg. So let's do 36 plus b squared is equal to 49. Okay, then we're going to subtract 36 from both sides, and I'm going to get b squared is equal to 49 minus 36 is going to be 13. Now, from here, I can take the square root of both sides, and I'm going to get that b is equal to radical 13. Okay, so I can fill in the missing side here as being the square root of 13. Okay, and this is simplified. There are no perfect squares, there are no fractions, there are no radicals in denominator, so I can leave it as that. Okay, and if you needed to, you could calculate this out. This would be somewhere between 3 and 4, probably about 3.6. Okay. But in this case, we can just leave it here. That's the simplest answer. Okay, well, let's move on and let's take a look at another one here. Why don't you go ahead, pause the video, and see if you can finish doing this one. Okay, find the missing side here. All right, well, hopefully you did a squared plus b squared is equal to c squared. And I'm going to plug in my values. This time I'll call this one a. So I know a squared plus 8 squared is equal to 12 squared. So I'm going to get a squared plus 64 is equal to 144. So a squared will be equal to 80, right? And I do that by subtracting 64 for both sides. And so a squared is equal to 80. Take the square root of this, take the square root of that, and I get a is equal to the square root of 80. Now, 80 has a perfect square in it. There's at least 4 in there, right? So this is going to be a is equal to the square root of 4 times 20. But 20 has a perfect square in it. So let's go ahead and make that a is equal to the square root of 4 times 4 times 5. So that means that a will be equal to 4 radical 5. That's my answer here. And so I'd plug it in here, and I would say that this is equal to 4 times the square root of 5. Okay? I know you guys have done this before. Just really kind of a review. So I need to make sure that you know how to do this, and also this thing called the converse of it. And we're going to use this idea to sort of, I've got an interesting activity I think we're going to try doing in class. So, well, I think it's interesting. We'll see if you do. Okay, why don't you go ahead, let's take a look at this one. This one adds our binomials into this a little bit. And so again, what we're going to do here is we're going to say a squared plus b squared is equal to c squared. And really, the most important thing that you always do is you identify which is which. And the most important one is to identify the hypotenuse. So in this case, this is c, we'll call this a, and we'll call this b. All right, so we're going to get x plus 2 squared plus x squared is going to be equal to radical 10 squared. Okay, now this is a binomial. We're going to square it. So if you remember, this is going to look like x squared plus 4x plus 4. Then we'll get plus x squared is equal to the radical 10 squared is going to be 10. 10. So we're going to go ahead and now let's go ahead and set this whole thing equal to 0. So we're going to get 2 squared plus 4x, okay, plus 4 equals 10. And then we'll subtract the 10 and we'll set this whole thing equals 0. So we'll get 2x squared plus 4x minus 6 is equal to 0. Now there's a factor of 2, so if I divide everything by 2, divide that side by 2, we're going to get x squared plus 2x minus 3 is equal to 0. And then I can look at this and I can look at what two factors of 3 subtract to get 2. So I could be 3 and 1. So we can do x minus or x plus 3, right? And x minus 1 is equal to 0. So I'm going to get x is equal to negative 3 or x is equal to 1. Okay? Let's take a look. Let me make sure that we did this right. Okay, x squared. Let's see. This is x squared plus 4x plus 4. It looks right. Plus x squared. Combine that 2x squared plus 4x plus 4. Okay, subtract 10, so I get negative 6. Divide everything by 2. So this is divide x squared. 2x, negative 3, 0 divided by 2 is 0, okay? And then I'm looking for what two factors, right, of negative 3 are going to give me positive 2, so x plus 3 and x minus 1. So let's see, x times x is x squared, and 3 times negative 1 is negative 3, that works, and then positive 3x and negative 1x will give me 2x, that looks right. Okay, so then I get negative 3 or 1. Now, if I plug this back in and I look, negative 3 doesn't work, okay? You can't have a side length here of negative 3. And if I plug in negative 3, that's not going to work either. So this is an extraneous solution. So let's try 1. If I put 1 here, okay, and then 1 plus 2 is 3. And let's see, 1 squared is 1, 3 squared is 9, 9 plus 1 is 10. If I take the square root of that, I'm going to get the square root of 10. Okay, so your solution here would be that x is equal to 1. Right. Now, there's also this thing called the converse of the Pythagorean theorem. And basically what it says is if you can use the Pythagorean theorem to find a missing side, then you can use the Pythagorean theorem to prove whether or not a triangle is a right triangle. Okay? Because this only works for right triangles, so we can use this to determine if it is a perfect or if it is a right triangle. So in this case, you just have to determine again which is the hypotenuse. Well, the hypotenuse always has to be the longest one, so that would be 17 here. So I'm going to do 8 squared plus 15 squared is equal to 17 squared. And we're going to test it. We're going to get 64 plus 225 is equal to, what is 17 squared? Let me think. I think it's, let's see, 15, 16 is 256. Let me see. Get a calculator out real quick. I don't remember. I'm having a hard time off the top of my head. 17 squared is 289. There we go. That makes sense. So 289. Add, we get 289 is equal to 289. So check. This is a right triangle. Okay, well, let's try this one. C squared here, C is going to be 9. So we're going to get 5 squared plus 8 squared is equal to 9 squared. And I'm going to get 25 plus 64. Is that going to be 81? And I can already tell it's not, because this, even if you just had 20, it's going to be more than 81. But we'll just go ahead and do this. So you're going to get 89. Is that equal to 81? That is not true. So this is not a right triangle. Okay? That's the converse. All right, it's just using it. You use the sides of a triangle to prove whether or not it is a right triangle or not. So, okay, you should have enough information. Really, all I want you to do with this is I just want you to practice. So go to Khan Academy, practice the Pythagorean theorem. Again, I would avoid logging on at first. Practice a couple times. You definitely want to use a calculator. There are plenty of calculators online if you don't have the one with you. Or use the one on your computer. Go ahead, do that, and then be prepared to do a little bit of an activity tomorrow. Okay? So, good luck.